Alright, today in this video I'm going to be talking about how to properly design a network. My name is CCNP Seth, and let's dive right into it. So, I've always wondered, how does a network, how is that really designed? Where do I put a switch? Where do I put a router? Where do I put this firewall? Where do I put my web server? We learned of all these great network devices, but we don't know how everything is supposed to connect. So there's many models out there, and I'm going to go over the Cisco Enterprise model. And you could find this online. There's many different sources on this. But if you really want to dig deep in design, you could actually look at this book. This is the Cisco Certified Design Associate. It is the CCNA equivalent, but instead of getting real technical, you learn overall big picture things. And this is the biggest thing that entry-level networking, security, system technicians, that's the big thing. Like, where does everything hook up? Where does this go? So I'm going to go over that right now. I'm going to go over the Enterprise Edge later, or the Enterprise Campus later, and I'm going to go over the Enterprise Edge right now. So let's dig into it. So if I scroll up and actually do this real quick, here we see the Enterprise Edge. What does that mean? Well, we have our network where we have our users, our main campus, if you want to say that, and then we have the edge of it, meaning it's about to touch the internet, and you could see that right here. All right, and then we have all these little modules that Cisco likes to call it. And we have the remote access module, the internet module, e-commerce, and the WAN module, and they all serve different purposes. The whole point of these modules is that your network, first of all, is modular, it's resilient, and when you want to add or take away a module, it won't affect other things. Okay? So let's start off with the e-commerce submodule. Now up here I have a high visibility statement on what the e-commerce submodule is, and basically it says it provides high available networks for business services. Now what does that mean? That just means if I'm holding some sort of business and I want all my business transactions, then it is going to go from the internet through this router, through my firewall, and hit my web servers and my database right here. Okay, the reason why you go through a router is because a router, it separates networks. Here's a network, here's a network, and then now, bam, I have a layer 3 device doing the routing. Now, in this e-commerce submodule, along with all these other submodules, you'll see it hits a router, and then it immediately hits a firewall. Okay, the reason why we have firewalls, because you know what a firewall does. It blocks things that we don't want to enter in. So as soon as we get to our router, which hooks up to the internet, and this is our ISP, Internet Service Provider, it's immediately going to get filtered. All right, so that's our first line of defense, is our DMZ firewall. Then in there, in this little circle right here, is where we have all of our e-commerce services. Now it says web server and app server and database and so on, so forth. If we have multiple web servers, like let's say I draw another line here and I have another web server. Well, this little patch right here, first of all, there's going to be a switch because you can't just put multiple cables together and make it work. So there's going to be a switch there. But also, you could put a load balancer. You could put a load balancer right there to load balance traffic. So as people come into your e-commerce web server, half the traffic is going to hit this web server, half the traffic is going to hit that web server. And that's what load balancers do. All right? Now, if for whatever reason, if that traffic needs to enter your campus, it's going to go through another firewall. All right? So now, what is this concept called when you have firewall after firewall, and then a router which has ACLs and stuff like that. That's called defense in depth. So that's what we want to have. Once you go through one device with ACLs, you go through another filtering device, go through another filtering device, so on and so forth. So it stops people from getting into our network, right? Defense in depth. Then we have the internet edge. Internet edge is basically just like e-commerce, except this is where we have public services. Public servers, email, DNS, a proxy server. Look at that. Caching, that's actually our proxy server right there. What do proxy servers do? Well, it's a device that we connect to, which actually surfs the internet for us. So if I have, let's say this is me right here, this is CCNP Seth, and I'm trying to get out to the internet, but I notice that I have a proxy server on my internet settings, or my IE settings, that it says, I need to go to that proxy server. Okay, cool. I connect to it, then I search the internet from my proxy server. So if someone on the internet were to see my public address, they wouldn't see my address that I'm actually using on this computer. They would see my proxy server's address, and that's what that does. Proxy servers also have filters too, more like web content, but that's just another device that would be in your internet submodule. And what I mean by internet submodule, it's just, me trying to get to the internet, so I'm going to take this route. I'm going to take that route. And again, we have firewall, public servers. Again, if we have multiple public servers doing the same thing, we could always throw a load balancer in there. All right, load balancer, anywhere you have multiple of the same servers and you want to load balance traffic, you could put it there. It doesn't have to be strictly in the data center. It could be anywhere. All right. Now, this last one, the remote access server, the remote access submodule. This is where you have all your VPN termination services, where let's say I am abroad and I'm not on my campus. Let's say I'm going on a trip, but yet I want to access the resources on my campus. So here, I got my little laptop, I'm connecting to the internet, and I want to reach the file server on my campus. Well, how do I get to it? Well, we talk about all these VPN technologies. Well, how does that actually terminate? Since I'm going through the internet, I will hit my internet submodule, which the router says, oh, you're trying to VPN in? Let me redirect your traffic to the VPN termination server. All right, the VPN concentrator. This VPN device could actually be a firewall as well, because firewalls will terminate VPN services. Firewalls can do a lot of things. And then from there, looks like I'm going through another firewall. Then it goes into my router, and then I could finally access that public server. So that's one thing for remote access. Also, in every submodule, I could have an IDS attached. The reason why you want IDS is in your enterprise edge submodules is just in case you are getting attacked. All right, just in case you are getting attacked, we can monitor it, and the only way that you could monitor it, stop it, do whatever you need to do to prevent attacks is implement IDSs or IPSs. IPSs are more inline, and they could actually physically stop the attack. IDSs, they are more of a promiscuous device where they get copies of the data that's going through the network. So it really can't stop it immediately. That's what IPSs do. And you could add an IPS right here. You could add an IPS right here as well. And this is also where you could have honeypots as well. Honeypots. Can't really spell. So you could put it anywhere in your enterprise edge device or enterprise edge module. Okay. WAN. Didn't really talk much about WAN, but what WANs do let me get rid of this real quick, is that it connects to other LANs. So let's say I'm a bank, and this is my headquarter bank. Then I have my little branch out here, you know, on the other side of the world, servicing customers, whatever. This WAN will give me a private connection to my branch service. And that's just what that WAN submodule is. All right. Now let's go to the campus, enterprise campus. One thing I want to point out here is, see how this says building access, building distribution, campus backbone? That is where all of these devices and users are going to be aggregated together, and then if they want to go out to the internet, they'll take that route like that. All right? But in this building access where this says floor 1, floor 2, floor 3, these are where users sit, and these are where VoIP phones are. And then let's say they want to access the file server or the SharePoint server or something like that. Here we have the server farm, and that's where all the main servers are. And again, when I mention multiple servers, what did I say? That we could have load balancers. So in the server farm, we'll have load balancers again, and email server, DNS server, file and print, Active Directory, the database, and the server farm is actually where the storage area network is. That's where all the hard drives are. That's where you can consider the SAN as the cloud. You guys ever heard that term before, the cloud? Cloud is just a service that has a whole bunch of hard drive space and free servers that could be used to the public. And that's what Amazon Web Services does. Google has their own cloud storage, stuff like that. So, yeah. So I think in a nutshell, this is what a topology could look like. And if you have all the money in the world, this is how it should look like. One big thing that I want to mention is, what's the difference between a router and a switch? A router has more processing power, so I'll just say PC power. It's got like a really strong CPU to do a lot of processing. A switch generally does not have as much PC power, but it also has many switch ports. Many switch ports. Routers do not. Routers are limited to 5, 10 maybe, where switches like these, and remember there's also layer 3 switches, switches could have hundreds, like literally hundreds of switch ports. Because look at all these links right here. It's connecting so many things together. So that's just what I want to point out when it comes to switches and routers, because there are layer 3 switches that can do routing capabilities, so then why don't we just get rid of routers? There are some things that layer 3 switches cannot do that routers can, and it's because of that CPU power that are built into routers. Okay? So that was a quick high-level overview on how a network and all these networking devices are applied and how Cisco thinks you should build your network on. And again, I mentioned this before at the very beginning. If you want to know more about this and how everything works, CCDA, all right? Cisco Certified Design Associate. So I hope you enjoyed this video. If you like it, please leave a comment below, subscribe, and if you have any questions, go ahead and leave it. So I hope this was informative for you, and I'd like to thank you for viewing.